Hello, this is the start to the Python demo that will align with any of the exercises in the textbook, and all of the code in here will be useful for your homework, and it will align pretty much one-to-one. So anything in this video and in this notebook, which will be linked to in Blackboard, will be helpful for the homework. So we'll go through it now, and all of these different this is really kind of getting on how do we actually do all the stuff that I was just talking about when it comes to working with data. So I will share my screen, and hopefully this all works this time, so I won't have to redo it. So you should be seeing a notebook called Concepts of Measurement, and this will have all the infrastructure in it, but we'll run through each line and see what happens. So to start off, we have our packages that we'll be using in this module at the top of the notebook. And I have a description of what will be in this notebook at the top. And that was one thing I noticed in some of the homeworks that was missing. So please, going forward, make sure in any notebook that you submit that you have just a general overview of what's going to be in this. And that, again, helps for reproducible research and helping other people be able to identify what it is that you're doing, especially me. So let's begin. The packages we'll be using is Pandas, which is used for any type of data wrangling in data frames. So you'll get familiar with that package. NumPy is working with numbers, and something like datetime, we'll be doing a little bit with wrangling with dates. So that's going to be a useful tool for us. And to iterate from our first module, you import these and save it as a nickname or an alias. So anytime we use PD, we'll be referencing pandas. And this just makes it a little bit more succinct when you're working with it. So we'll just run this cell and we will go through the notebook. So it's just loading, getting everything moving along. So while that loads, let's talk about what we will be diving into, which is concepts of measurement. All right, we got our little check. That's good. Anytime we're going to just start with, how do we even import data? How do we work with it? And anytime we work with data in our notebook, we want to ensure that our analysis is reproducible. Therefore, we should link directly to the location of the data we sourced so that anyone can refer to it, download it themselves, and replicate our analysis. So in short, whenever you download data, we're going to make sure that the link that you use is actually directly sourced to the data. This is in comparison to you manually downloading it, saving it somewhere on your desktop in your own personal folder, and then just pointing to that folder later in your analysis. If I wanted to reproduce what you did, I have no idea where you sourced that data from, so I can't replicate exactly what you did. So in short, do make sure you right click, which is what I'm showing here in this example of we'll be working with Zillow. They have some nice little data sets that are I always want to use like more real world stuff in this class. And you can right click on it, which I just showed in this screenshot. And what you want to do is copy link address. What you don't want to do is download this file somewhere in a folder and then point to it and read it in as data. So we'll show you what that looks like. Maybe it might be helpful just to show you on Zillow's website. They have some cool stuff on here, such as like home values, forecasts, inventory, some neat stuff. So we'll be working right now with the Zillow Observed Rent Index. Actually, which one did we? I think I played around with a couple different things, but this one might just be the home values forecast data. So this is how we would read it in. And notice I have some comments here in Markdown, just talking about the steps we took. So let's run this, which I'm saving this data frame. So going back to that link I just had from here, instead of downloading it, I just right click and say copy link address. We put that here. And then that's exactly what we would paste in here. And that's what you see here. So that way, anytime I run this, it'll just directly link from there. And another benefit of this is in case they update it, you'll always have the link back to where it came from. So let's see what's in this thing. We just downloaded data that took one line of code. And it's usually helpful to look inside of it, see what's in it, what are we working with, how messy is this thing sometimes is the question. So a helpful function to use is the dot head or dot tail function. And this will show the top first 5 rows for head and 5 bottom rows for tail. So let's see, we call this variable we just saved, which is data frame df, which was the data frame that we read in using the CSV because it was a CSV file. And now let's see what this looks like by calling df.head. And we see we have something like the region, the state, the county name, the forecasted date. And again, this is probably the key value that if we were doing analysis on what is the forecasted price, we would use this type of feature. So let's also look at the tail, because sometimes there's always little nuances at the end and at the beginning, because we see here, like this is a country compared to everything else is MSA. And then in the bottom, we see like zip code as the region. So it's generally good to just have a basis of understanding of what it is you're working with. Another example I wanted to show you from is using a package for working with any Yahoo. If you're into different type of investing and you want to know prices and be able to work with this data kind of in a native environment, you might use something called Y-Finance, which is just someone built this package to download market data. And I wanted to show you this also as an example of a package that's not already pre-installed in Google Colab's environment. And this isn't too critical because again, all the code that we'll be working with, you'll already have it here. But I just wanted to show you what it might look like when we use something called pip, which is just the package manager. Whenever we want to use new things that's not already there, we can still stay within our notebook, which is pretty convenient. And I'll show you what that looks like. So if I tried to install it, which this you can just look up online when you look at Y-Finance, how do you import it? We see module not found error, that this doesn't exist. So we need to download it, and we can use that just by using this pip install Y-Finance. And you have this exclamation point in the front. That's the command for using a terminal command in here. And terminal command just means it's talking directly to the computer, like all your package management, rather than necessarily like a cell in your notebook of working with the data frame. But again, don't worry too much about this. I just wanted to show you for an example if you wanted to work with other things, such as using Yahoo data, which I think is handy. So now we see that it was successfully installed. That's good. Now let's try this again to import it. And I'm being a little hypocritical with my first statement when we said we should have all packages imported at the top. So let me follow my own rules and put this up here. I just put it down there just more for the sequence of going through the demo, but we should have all of our packages at the top. Alrighty. And we'll put that there. And now that we already installed this, we don't really need this line anymore, but I'll keep it because anytime you reopen a notebook, it forgets what was installed there. That's kind of part of being on the cloud. Nothing's necessarily going to your computer directly. So you'll have to reinstall if you wanted to use it again. So we'll just comment that out, but leave it here for future reference. Great. Now we can download a lot of time series stuff about stock price. So let's look at Microsoft and let's practice looking at what is their stock price from the last year. So we would now use this package, which we downloaded called YF, and let's download Microsoft, use just the ticker. And again, this would all be syntax you could look up when you are using this package. So you would say start from here and let's go here. I don't remember what progress means, but I'm sure if you highlight over here, it'll show you all the different parameters that you can use from. So progress, now we can see what does progress mean? Well, it has it as one of the parameters. We'll just keep it as false for now. But if we were kind of curious more, we would look into it. But for purposes, we're fine. So we'll run this. And we can see now we have the open, high, low, close, adjusted close, and the volume over this date period, because I ran we saved this as a variable similar to that first example of the Zillow data frame, and now we're looking at just the head. And there are a lot more functions and features that are included with this package. And there's a neat tutorial found here. Again, I'm giving direct reference to the code that you might use for it. And another resource that anyone kind of in the data science field might want to be familiar with is called Towards Data Science on Medium. And they have a lot of great workflows that provide the exact code you might use for other things. So really, when in doubt, Google's your best friend, and Stack Overflow is usually what shows up first when you're trying to troubleshoot something. So knowing how to ask the question is really the key part. All right, so getting into more of how do we work with this data? Those were just two examples of how you would read in data. One was directly from a link online, which the majority of our textbook assignments will look like this, where it'll be a direct link. And then now we'll talk about how we actually start counting and sorting and working with this data. So this is an example from the textbook where I try to make them a little bit more interesting. Sometimes they're a little dry, so I try to bring other context to it. But really the core concepts are pretty much aligned with what's in the textbook here. So let's say you're a manager at a company that's trying to match independent gig workers to a job based on the industry, and you have employee data from their most recent work experience. So you're trying to just match different gig workers to needs. And we want to find the number of missing observations that we might have in our variables, since when they're collecting this data, if a gig worker didn't necessarily complete something and then they go off, it's hard to necessarily call them back and get the data. So we might have missing data, which this would be representative of like more real world data. And we'll also talk about other summary statistics, like what is the number of employees that worked in the automotive industry? How many employees earned more than $30 an hour? And so on and so forth. So we'll walk through these. This is how, this is probably one of the more important lines of code in this notebook, because this is how for all homework examples, you will be able to read in the data. And that's why I recommended getting the textbook online, because it provides direct access right in downloading it. So you would take a right click on the textbook link and provide the full data set. So let me show how this looks. If you have any questions, we'll import from here. I think I should let me stop sharing my screen for a second just to show you what that looks like. All right, sharing my screen again. So this is what, chapter 1, this is really what we're working with. And you would see here is a file that would link directly to the homework. And I right click, and similar with Zillow, you just say copy link address. And that's what I then put into the other screen. So that's all I really want to show here. Then now we'll go back to the notebook. So I'll share my screen again. All right. And that's what we have here. So what I just copied there, I'll just to show you, we copy and paste it. It's exactly from there. So now we're able to access it. The only key part is, depending on the exercise homework we're working with, you just write what's the sheet name. And sometimes it is a good idea to download the data and like open it up in Excel or Google Sheets just to see what's the format. But once you kind of know what it is you're working with, you can get right into it. So this is what that data looks like. We have employee ID, their wage, what industry they're in, and what was their job title. Another handy function is using something called shape, which will give you the parameters of how large is this. So we know how many rows and how many columns. That's what this tuple is showing you, where we have 604 different observations and we have our 4 columns here. And again, when you're working with larger data sets, this is really helpful to generally grasp what it is you're working with. All right, so our first item to go through is how many missing observations were there. This is a syntax for what you can use is say, in this data frame, that's what we saved as gig here, how many are missing, or is NA, similar to that example around the toilet paper rolls. NA is like not a value. So NA, that's how you ask, is how many of these are missing any data points, and how many are there, the sum. So we run this and we see the industry and job have missing values. And that doesn't mean if the industry is missing that, they didn't work in an industry. It just means that it's missing that value. And from the Statistics in a Nutshell textbook, they have a nice little segment on what to do with missing data. And throughout our class, we really won't worry about this too much, but you should be exposed to it if you're working with real world data, that there's a few different ways that we can handle it. One thing is to try to find that missing data, for example, calling that gig worker and saying, what was your industry? But usually that's not feasible. So there's other analytical approaches you can take. And really this just comes down to your critical thinking and like understanding of what is the risk of doing this. And again, these are all assumptions that you should clearly define whenever you're working with real world data. Another thing you can do is include a dummy variable that indicates that this is missing. So maybe you would say unknown. You can impute it, such as taking the average. If this was something like a number, when we're talking about their wage, if that was missing, you might just take the average. Or you can drop it, say, we're just not even gonna look at this. Sometimes that's useful if you don't necessarily trust this observation. So for that gig worker who didn't say their industry, can we really trust what their wage was if they didn't even input this other one? So again, this is really bringing subject matter expertise into the analysis and really thinking about what would be the downfalls to your decision that you include. So this is bringing us back to bias and how your bias on how you work with data will totally change the outcomes. So anyway, you can read through this a little bit more if you'd like to. This is the TLDR. These are kind of like the three main things you can do with it. So I always find it handy even just to like look at the data of where it's missing. And this is an example of how we would slice a data frame to look at. Through this data frame, we're looking just at the columns where industry column is missing. And now we see those, I think it was 16, or no, this one was just 10. So we'll see 10 rows where industry, and we see that NAN, which is not a number. It's not anything. There's nothing there. And it's handy, we see that job is actually filled in for all of these in wage. So we can drop these, we can take the average. Depending on your analysis, you might change it. So now let's also look at where job data is missing, and we just change the column name that we're looking for. So instead of industry, we have job, and let's see what that looks like. And this was the one where we had 16, and we see everything else is there. And because these are categorical variables and not numerical, we cannot simply impute the average as if it was the wage. So we can either drop these rows, particularly maybe because it's only a really small subset compared to the 600 rows we had. That could be fine. Or we can leave them as missing and exclude these rows when we had to calculate values when analyzing when it relates to the industry or job. So we might be more inclined to remove these rows if we had some guidance as to like, why are they missing? But for now, we'll kind of leave it as is, but it's good to know when we're calculating an average for an industry that we might be missing these 10 rows and how that might skew our outcome. That's really the crux of what we're getting at here. So now when we try to calculate some of these different data points, we can say, let's filter to when the industry is equal to automotive. Actually, one thing just to show before that is kind of handy just to see all the different values that might exist for the industry. So you would do something like gig, which is the data frame. Let's look at industry, which this is just another way to show rather than use those parentheses with the value in it, just having this dot for that column is another way to have that. So that's sometimes when you're working with variables, when there's spaces and there's 2 words, it's usually best practices to keep things as 1 word and actually lowercase, but that's a little out of scope what we're talking about. So using value counts, we can see these are the 3 different options. We see 366 examples are construction, 190 are automotive, and 38 are in the tech industry. So let's filter to all the rows where industry equals automotive. And we use these 2 equal signs, which is different than when you are assigning a variable, which is just has 1. 2 means let's find all the things that are equal to this. So let's hit run. And we know that there was 190. We don't see all 190 rows here. We just automatically see the top 5 and the last 5. So it truncates it where you see these ellipses in the middle. But we can use the dot shape similar to seeing the whole data frame. Now we have this little slice of anytime the industry is automotive, and we see shape, which is 190, which exactly aligns with what we saw here from this value counts. So now we can answer this exercise and say there are 190 employees that work in the automotive sector. If we wanted to see all the unique types of industries, once we get into that, this is I guess I already covered this down here. I got a little ahead of myself before. But this is another way of seeing like all the different values as unique, where we have construction, automotive, tech. One thing that now showed up that we didn't see in the value counts is this missing one of NaN, which is helpful to know that this is another way to see like, we have missing data here. And this is now just repetitive of what we had there before. But maybe for sake of just showing something else, now we have job. We can see, I'll change this to what job appears the most. Just by changing the feature column name, now we can see, and it sorts it too, which is kind of handy. Alrighty. So now to answer the next question of how many employees earned more than $30 an hour. This is another way just to filter rather than say what we did up here, where we had it equal to this category, this categorical variable. Now we're saying how many are greater than 30. And we use that dot shape to give us the total count. And this will have 536, which would be our answer for that. When you're working in our homework examples, in order to make it very straightforward and not have any uncertainty with what your answer is, I request that you use this format, which was discussed from the syntax examples you had, where you have this print statement and you have the answer in quotes. And then within that, you can use these curly brackets to say, just have exactly that code of what we have in here. So when we hit run, this is perfect. For any homework assignment, I would love to see something like this, where you have exactly the answer to the question. And you can use this formatting. So definitely feel free to reach out if you have any questions on how this works. But pretty much anything within curly brackets, when you have this F in front of it, will run as a string, but it's code itself. So really, this is just exactly this. And by taking this 0 index, we're just taking that first value. So that would be exactly looking like that, which we just put it in there. So for now, I'll leave that there. So some of the other options of slicing and dicing, thinking of these inequality statements, if we wanted to calculate less than or equal to 30, how many are there? So really, this is just a very quick way to get you exactly the type of information you're looking for. This is similar to equal to if we wanted to know how many are exactly 41. We can also know the not, how many are not equal to 41. And we see that, the majority are not equal to that. So these are just other ways that you can get to exactly the data that you're looking for. And everything is in this format of this is the data frame, and then just give me the rows that match this parameter. All right, so now if we wanted to answer the question, get a little bit more detailed, how many earn over $30 an hour and are in the automotive industry? So now we added in parentheses, we're filtering to anything over 30, and then how many are equal to automotive. So we're just putting the pieces together now. So we'll run this and see the shape. And now we have our answer, which is 181. So similar to what we went through with in the first module, we'll save this where now we only have one variable where we're using an equal sign. So just one equals. Now that means we're saving this value as an answer. So we're saving this variable as answer 4 for the homework question that you're working with. This would be the best way to show it. So if you wanted to get a little bit more creative and not do exactly this way, really the important part is that it's crystal clear what it is that we are answering. So I just had an error, which I always like to just talk about the errors we see, because this, if I wanted to figure out what's a name error, it pretty much tells you, oh, I never defined this variable, so it has no idea what to put in this formatted box. So, and it's because we didn't run this cell. So now that we run that, now we have a definition. When we put it below, we see answer 4. And now let's click this again. So this is how this would be the best way to have it. So I would really encourage you, if I can't tell what answer is, I will have to deduct points, but it doesn't necessarily be exactly like this. But really, it just needs to be very crystal clear what it is the answer has. So there are 181 employees that earn, X and are in the automotive industry. So now let's go on to the next example, where we want to know the hourly wage of the lowest and highest paid employees at the company as a whole. And there are many ways we can calculate this, but one that I'll use is, this is kind of like a handy catch-all for when you're exploring your data, called .describe. And that'll provide you how many values you see, what's the average, standard deviation, what's the min, and what's the max. And we'll get into a little bit more of what this means when we talk about percentiles. But for now, you see the first quarter percentile, the middle, which you can see the middle is kind of similar to the mean. So if we think of median, that's what we're looking at here, but not trying to get ahead of future classes here. And then the 75th percentile. So other ways we can get this again is just your handy bin that looks at any numerical value. So we see for employee ID, which was just a tag for which employee this is. These aren't too meaningful, but something like wage, this column is very helpful to know. So now we can have other ways. If we're just looking for min and max, we can use these functions, .min. And just by running this, we see the same exact things that are up here, where the minimum wage is $24.28 per hour, and the maximum wage is $51 per hour. Next, if we wanted to sort our data frame, we can use something called sort values. And you just have to say, which column do we want to sort by? And I added this function. And the nice part, we really like build off of things. Think of it kind of like Legos. You continue to put blocks on the next one. So we have, this is the first block. This is the data frame. This is the second block, which is the function of I want to sort by wage. And this is the third block of saying, of all that, just show me the top 5. So we run this and we see that we sorted by wage, but it actually it goes from lowest to highest. So this actually shows us the lowest 5 wages, where we see this value we found here, which was $24.28. And now we can start to kind of get a little bit more into like, oh, okay, which industry has the lowest wage compared to the highest, and what was the job role? If we wanted to see the wages that are at the top, we would just use this parameter called ascending equals false. So that really just changes the order. And now it gives you the top ones. So we now see, okay, these are the top wages, which we saw before 51 was also in the construction industry. So if that was some type of insight, you see, just because you're in the construction industry, you can have the lowest or the highest. So just to answer the question for the textbook, again, I print it like this, and it's crystal clear when I'm answering this homework assignment question is the minimum value is this and the maximum value is that. And just to really hit that point home, stopping here you are answering the question, but what I'm expecting to get full credit is something like this, where it really is the written out version. And, as we're starting off, I'll be a little bit more lenient, but as we get further in the semester, I will not be able to grant full credit when I can't know what exactly is where, because things are going to get a little bit more complex, and having those answers be very explicit is important. All right, so bringing this back to when we're slicing and dicing the data, this would be an example of saying or. So if we want to know what is the hourly wage of the lowest and highest paid accountants who work in the automotive or tech industry. So we would want to create a new variable for this. There's lots of ways to, to think about it, of how you can accomplish the task. So there's no one correct way. This is just the way I have it. So feel free to find other ways. But this is how we would say you can be in the industry equals automotive, or you can say you can be in the industry of tech. So we're now looking into automotive and tech industry. Since these are mutually exclusive, you can't be both tech and automotive. We use the or. So this creates that new subset. One thing to notice, nothing was returned, nothing was printed out here. And that's because we save this as a new variable. So that's just a good thing to keep in mind when you're troubleshooting. When you return something, like when I just say, let's look at this dot head, this is returned. That means it's not being saved as something new. When we ran this, nothing was returned. So that's a good sign that you just created a variable that was saved somewhere. So now we see that the industry is up here as automotive, but let's see what the tail looks like. Okay, so probably the majority are, but let's, it's always good to, for sanity check, let's make sure our above thing worked. So I would expect to see only automotive or tech here, and that's good. That's what we see. All right, now to answer the other part of the question is, we only want accountants who work in the automotive and tech industry. So now we created this little subset, and now we're looking just when the job is equal to accountant. And just a little bit of an aside, we could have put this all in one column and added a third parameter, but sometimes it's good to just be more explicit and compartmentalize things. So again, there's lots of ways you can accomplish this, but this is the one I chose. So now from this industry subset, we overrode that variable, and now we said, just give me the industry subset where the job is equal to accountant. And let's see how many fit this. There's 35 total. And now, since we have exactly this little sliver of data we want, we can use the same things we talked about before, which is look at what's the minimum and what's the maximum. So we use this little print, and now we have everything that's there. And that would be the answer to this homework assignment. All right. How are we doing? Okay, no answer, that's fine. Anyway, okay, let's move on to subsetting. This is now a different homework exercise where we see the same, we're reading it in from directly there. And now this is just a new sheet name because this is a new subset within this giant Excel file of customers. So this is a case study that looks at customer demographic data. We're going to identify different college-educated millennial customers in this data set. So maybe you're in marketing and you want to know, how do we target the right demographics for this new product? You need to first look at the data that fit those parameters. So we're going to create a subset of male, female, college-educated, and get right to this age demographic that we want. So then we could provide a summary of these results. So this is all descriptive rather than inferential when we just circling back to our presentation slide deck. So as always, it's always a good idea. Just let's see the format of what this data is that we just downloaded. And we see similar, we have like customer ID, we see sex, we see race, birth date, if they went to college. I'm not too sure what this one means, their income, spending, how many orders did they have, and what channel did they did they make the order from? But again, there's probably more information about this in the textbook of what it is we're working with. Let's see the total shape of how many observations do we have. We see there's 200 rows, and then these are the columns. So we have 10 columns. It's good, just let's see how many are missing. Always nice just to know general understanding of the data you're working with. Maybe HH is household size, just going off a hunch. So we see there's no missing values. So if we wanted to see what are the different options of college, because sometimes even just judging from this, if we see sex, female, male, there might, be other types of classification. So it's good just to see what are the different things. You can use that dot unique, but sometimes it's easier to even just see dot value counts to know, okay, the majority are yes, and there's this other portion that's no. So now if we wanted to identify only the college educated, we'll get to the millennial side of things, but first we'll just create this subset similar to what we just talked about with looking at industry to college equals yes. And so we match that exactly when we look at the shape. And we don't actually have an age variable. We have their birth date, and we're going to get a little funky. And like, this is just an example of how you can create like a new variable based off of the data you have. So in, the data science world, you might call this feature engineering. So we'll go through what that might look like. So if we wanted to get just the age of everyone, since we have their birth date, we could, filter between the different age ranges that would be from, 1990 to 2000 and call this our demographic range. Or we can now say, let's subtract today's date from this date to actually give you a value of how old this person is. That's what I'm going to run through. It's a little bit more technical, but it's cool because you might use this in real world if you're trying to calculate the difference between a date you have and today to know like what's the age of this variable. So this is a handy function that I talked about at the top, which is just called date time, and it could give you exactly today's date. So you'll see when I was running this, even to like the millisecond of time when I say, what is this? So if I ran it again, this will change slightly. It's been 3 more seconds. All right. But you see, this is the year, this is the day, the month, and this is the day. This is an example of writing a function that returns the difference of days between dates. So it takes the difference between this input and that input, which stands for like date 1 and date 2. And then it takes how many days passed and like the absolute value. We don't want any negative days if they're, and then we would take, we would convert this to years by just dividing it by 365 and rounding this to a whole number. And let's see how this would look. So this is just one example of, let's just take the first observation in the head of our data of birth date and the college data frame. So we see the first one. It's always sometimes good when you're working through something, like let's just take one little bit and extrapolate it to everything else. So now we'll apply our function of days between, and our first input is this example of 1986. And we'll use today's date to say how many years have elapsed since this date. So we'll hit run and we get our answer, which is 35. So someone born in 1986 would be 35 years old today. And now we can create a new column and apply this function. So we do that by adding this column here. So we're saying college, create a new column called age. And we do this by applying our function. This is getting a little bit more into some more advanced Python stuff. And again, you'll never really need to write this from scratch. Like you'll always have an example there to work with. So we say, take this column, and on each row, that's what this means. On each row of X is saying the variable for row. So for each row of birth date, apply our function of say, take that value of X, similar to here where it was 1986, and subtract the difference between today's date. And it'll give us a warning because this actually isn't the best way to create a new column. They've changed it over time, but I think this is kind of as we're starting to learn, I think it's kind of more clear this way, but it'll tell you this warning where we should use this type of slice indexing. So maybe in the future, I'll use that syntax, but for now, it gets the job done. This is an example of how it would look in the way that won't throw you a warning, but it doesn't mean, we still have it here if we wanted to look. Or I have it right here of how that might look. We have the age here. So it still ran. It didn't give us an error. It just gave us a warning, setting with copy warning. So this is the right way to do it, where we use this dot loc of give me all of the rows that are in this data frame and create a new column called age by doing the same exact thing. So I just wanted to show you both ways if we wanted to do that. Now it'll actually give us the same warning. But yeah, it's all right. You have what we need to get done, which is this age. All right, so now you're in the marketing department, maybe concepts of what, different millennials are different for you. Like what does it even mean to be a millennial? So we can define it. Let's just say it's over the age of 25 and less than 40 right now. So this generation, this is what we want. And we filter to that way. And now since we have this age, we can do it exactly using the feature that we just created. If we wanted to go just over, find the date of what would be 25, what would be 40, we could have done that way and then filtered to that, to those strings. So I'll show you how that would look too. But for now, I like the way we did it. So now we can see what type of data type this is, which this just stands for, it's like a date time. Oh, this is what I was just talking about. So we could have used the date itself, but actually it got a lot more nuanced because we needed to convert these. Right now, it just sees it as a string. So it has no idea. This is kind of like almost like an ordinal data set rather than like an interval of saying from 1981 to 1996. It only sees these are like categories. It has no idea that it's a date yet. So we have to convert that into a birth date time by using this toDate time, make it a date, and then we define new variables for our lower cutoff and our higher cutoff by doing the same thing. So this, I just researched like what age would you need to be 25, what would be for 40. And that is our cutoff boundaries. And now we can filter to those where we say we need to be older than our lower cutoff and younger than our higher cutoff. And now we have, it was really just showing you how there's lots of ways to do this. And this is the other way you could have done it. And let's just make sure that how we did it, they're equal to each other. So this is always nice when you're going through things to just give yourself some sanity and say, are these data frames we just made where this is college millennial _1, is that equal to our approach where we created the age column, where the second approach, we used the date and we just filtered between dates, which that's the version the textbook showed. And we could say, true, they are the same exact shape, which is good. That means we were able to do it both ways. And now to actually answer our question, once we did this slicing and dicing, now we can do it again and say how many are male or female. And we now have the shape, and this is our goal of the outcome. So now I would print this, and this would be to get full credit on your homework assignment to say there are 107 male college educated millennials and 61. Oh, see, I had a little mistake here. So this one's male, this one's female. So now we have our answer. Lastly, if we wanted to analyze the average income, spending, and orders of this demographic, now that we did all that work just to get the subset of data we wanted, now we can do a lot of stuff with it. So that's kind of, this is an example of like how much time it took us just to pre-process the data, and now we can actually do the analysis with it. So this actually was pretty representative of like how much time it would take compared to what is the actual objective outcome here. So let's see all the columns that are available, and we'll just filter to, excuse me. Now we can filter just to the columns of interest here, which we want to know the average income. Excuse me again. All right. We're almost at the end here, so we're good. We have income, spending, orders, and age. And we'll get more into kind of what this means when we talk about average. But for now, I'll just show you how we would calculate this in a very straightforward way, where we can actually say, let's group by this variable of sex. So we're going to say, give me all the male or female, rather than necessarily just filtering to that subset. We can say, let's group by, and then give me all of these columns that we just defined up here. So for income, spending, orders, and age, we're filtering to those rows, and then give me the average or the mean. And we have it here to say for between male and female, these are the different averages. And now if we're trying to do some analysis, let's say you want to know who exactly should you be targeting, this would be a good way to actually start summarizing your data. And with that, we are finished. So now you have all the code you need to answer the first homework. So please feel free to reach out with any questions, and best of luck.